Welcome back, Mindsetters. I know that was a really quick break, but time does go fast when we are having fun, so we like to have you back. We are doing data handling and data manipulation. I hope you guys are already on the ball and you're on your calculators as well, because it is such an awesome show. And today is also a very special day because we went way over the 16,000 mark. We started with 15,994, and now we are actually on 16,038. So today only we've had like over 40 likes on the page. So it's really awesome. And if you still want to like the page, please go on and do that now, because we will be reaching 17,000 soon. And I know that you want to be part of that mark. Heather, are you ready for us?
Super. Okay, let's get going again. All right, guys, so firstly we did the median, the upper quartile, the lower quartile. We also did a box plot. We did an ogive. Now we've done the estimated mean, and we've also done the estimated standard deviation. Now what I want us to just have a look at is putting all this information together, because that's what you have to do with the data, and statistics is to interpret what you've got. So now, the one thing that we haven't spoken about in terms of data is the range. Now, if we have a look at the range of this data, you take your upper limit minus your lowest. Now, remember that was 30 minus 11. So that was spreading over 19 different times, okay? That's your range. But let's have a look at this middle 50% here. Can you see that this middle 50% is much more condensed or clustered, whereas this tail is quite long, and that piece there is actually a little bit longer as well than either of those two boxes. So the one thing that they often ask us is this data symmetrical or is it skewed? Right, so let's have a look. The question is the data symmetrical, or is it skewed? All right, now I'm looking at this data, and what I can see is that this box is a little bit shifted to the right. So it means that I'm looking at this and I see that there are fewer, items of data down in the lower side, and there are more items of data to the right. So it's definitely not symmetrical. All right? Now, how do we describe this asymmetrical thing? Well, we either talk about data as being skewed left, and the alternative to that is skewed right. And then the other way of talking about it is to be negatively skewed, all right, as opposed to positively skewed. Right, now you must decide which of these you prefer. So what I always do is I have a look at which way the graph is tailed. Okay, now can you see this has got a long tail and then lots of data. So in fact, this is being pulled out to the left, okay, which is being pulled to the negative numbers. So this particular graph, I would either describe as being skewed to the left, or I could describe it as being negatively skewed. Okay? What would data look like that was skewed right or positively skewed? Well, let's say I had something like this. All right? With my minimum there and my maximum there, then can you see that you've got your bulk of your data over here? It's been pulled off to the right. So this one would be skewed right, or otherwise we could say that it is positively skewed. Okay, so I hope that I've cleared up something there about skewness. All right. The other thing that we need to have a look at is the relationship between the mean and the median. Now, our mean was 21,58, and our median was not much more than that. It worked out to be 22. All right? They're very, very close. So although this data is skewed, it's not massively skewed. All right? But when your mean is less than your median, all right, that normally gives you an indication that it is skewed to the left. All right? So whichever way your mean is being pulled, it's being pulled to the lesser side, it's skewed left. And by comparison, if your mean is bigger than your median, then it is skewed right. Okay, so that's just something, pulling all of those measures of central tendency together. All right, let's have a look at a second question, also out of a final paper. And this one is slightly different because it gives you data of energy levels in kilocalories per 100 grams of 10 different snack foods. And it gives you the 10 different snack foods. Okay? Notice that it's not group data anymore, it's items of data. So the first snack food had a reading or a level of 440, 520, 480, etc. Now it says calculate the mean energy level. Now guys, can you see that it's not estimate the mean, it's calculate the mean, because you're putting in actually specific values, all right? You're going to get the exact answer. All right, now I'm not going to labor this, but I do need to go to the calculator to put it in for us. So we're just going to clear, and I'm quickly going to put in those values, so because I need it for the standard deviation. So we're going to go 440, then we're going to go 480, then we're going to go 490. Oh, hang on. Let's first of all make sure that we're in the right goodie. We need to be in 1. So let's go again. 440. Okay, 480. 490. 520. 545. 550. 560. 615. 620 and 680. Okay, and notice that the frequency each time was 1. Right, then if I go to my stat and I go back to number 4 and I choose my mean, it tells me that my mean is 550. Now remember, in order to get your mean, what you really are doing is you're adding up those 10 numbers and you're going to divide by 10. So literally, you are taking your 440 and your 520, etc., 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 and you are dividing by 10, and you get an answer of 550. And that is exactly the mean. Okay? Right, moving on. It says calculate the standard deviation, but using the table below. Now, if they didn't say using the table below, then what you would be able to do is you would be able to go and using what you've just done, you would be able to then go and get your standard deviation, which is number 3, and it tells you that your standard deviation to, let's say, 2 decimal places is 69.03. So that gives us our standard deviation is 69.03. But they didn't say, just do it the easy way. They want you to use the table below. Now, I did say that I was going to take the liberty of having done some of this for you. So they would give you the x's with all of the x data. They would give you the heading of x minus the mean, and they would give you the heading of x minus the mean squared. And you would have to fill this all in, and it is terribly tedious, and you have to just rely on your calculator. So remember that we worked out our mean to be 550. So if we take this data item of 440 and we subtract 550, we get negative 110. If we take 520 and we subtract 550, we get negative 30. And so you can see how I arrive at each of those values. Now remember that each of these values is the difference between the score and the mean. Okay, so some of them are positive, some of them are negative. And if you have to add all of those up, they will definitely come to 0 because they balance around the mean. Okay? Now, some being positive and some being negative is an issue. So the only way that we can get out of that positive and negative trap is to actually square. So if I take negative 110 and square it, I get that. Negative 30 squared, negative 70 squared, 10 squared, 65 squared. So this is quite easily just that column squared. Okay? Now, to get to your standard deviation, what we need to do is sum all of those. So that answer there is the sum of all the squares differenced. Okay, so we add all of those up. Then what we do is we divide that by 10 because there are 10 scores. And finally, if we take that number, 47650, so let's go to our calculator, and let's take our 47650, and we divide it by 10, all right? Now, if we square root that, we get the same answer that we got before of 69.03. Okay, so we get our answer of 69.03. So guys, can you see it's very important to follow instruction? Why go through this if you can just do it on your calculator the old way? Look at the mark allocation. If it's worth 2 or 3 marks, you can guarantee that it's just straight calculator work. This is also calculator work, but you can see that what you have to do is you have to fill out the body of a table, and they will instruct you to do that, and they will normally give you this table on the diagram sheet. Okay. All right, now, let's go back to this original. Do you agree that this is itemized data? We have found the exact mean and we found the exact standard deviation. What else could we do with this data? We could find the median, we could find the lower quartile, and we could find the upper quartile. Okay? Now notice, to find the median, you don't have to draw an ogive and read off positions. All that you have to do is actually take your data, and the first thing you have to do is rank it from smallest to biggest. So I've got that, and I'm just going to quickly write down these values from smallest to biggest. So where that came from, we're not sure. So 440, all right, then 480, then 490, 520, okay, 545, 550, 560, 615, okay, nearly there, 620, don't fall asleep, and 680. Okay, so guys, what I've done is I've ranked it from smallest to biggest, okay? Now, I know that a whole lot of debate goes into finding the values of the median, the upper quartile, and the lower quartile. And there's huge debate as to what formula to use. But really, when you've got 10 scores, use your eye, okay? Rather than using complicated formulas, use your eye, and I'll show you what I mean. We've got 10 scores, so that means that the middle must be 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So we've got 5 scores below that green line and 5 scores above. Now, doesn't it make sense then that if that is going to be our middle, we're going to have to take the average of those two numbers? So it's literally going to be 5, 4, 5, add 550 divided by 2, and that's going to give me 547 and a half. Okay? Now, if I want my upper and my lower quartile, let's do lower quartile first. Can you see that by creating your median, you have actually separated or split your whole data set into two halves? This half has got 5 numbers in it, and this half has got 5 numbers in it. So look at this as being one data set. Now can you see that you've got 5 numbers in this bottom 50% of the data? And if we have to go to the middle of that, it would be the number 490. So my lower quartile is going to literally be 490. And my upper quartile, again, I've got 5 numbers. And so the middle number is going to be 615. So median, upper quartile, lower quartile. Now, I know that some of you are jumping up and down and saying, but my teacher says. Now, yes, but your teacher says is fine. Some of your teachers, absolutely correctly, tell you that your lower quartile is in the n plus 1 over 4 position. Okay, so in other words, you have to say how many scores have you got? Well, you've got 10 scores, so 10 add 1 becomes 11, divided by 4, and 11 divided by 4 is going to go 2 3/4 position. Right, so now you have to go into this ranked data, and you have to find the number that is in the 2 3/4 position. Now, frankly, that's the first position, that's the second position, that's the third position. So now, at school level, you have to say to yourself, what is 2 3/4 closer to? The second position or the third position? So that means that we're actually going to get it in the third position, alrighty? And that means, again, that we're going to take that number. All right, and wasn't it just easier to do it with your eye? Okay.
Can we take a quick break here? Before
Exactly
you
my
continue?
thoughts.
Let's do that.
Great.
Great minds think alike.
Fools don't differ.
Yes. We're going to go for a quick ad break, guys. If at this point you guys do have questions, please don't fear. Please ask us what they are. Cheers, guys. See you after the break.
DSTV is all about more. Yep, more action, more stars, more entertainment, plus more bouquet options to suit every pocket and viewing taste.
It's exciting.
And what's more, our premium bouquet now offers you more than ever before. Over 90 incredible channels with more for everyone in the family, including 6 HD channels, giving you more clarity, more color, more blow-you-away viewing.
I want more. Hell yeah.
How about DSTV On Demand, a selection of the week's most popular series and sporting highlights at your fingertips 24/7.
Hello.
Box Office, a handy service that lets you rent Hollywood's latest blockbusters from the comfort of your couch. And subscription to DSTV Mobile, so you can take your DSTV with you wherever you go.
So much more.
So, if it's more you want, look no further than DSTV Premium. So much more, really.
Unbeatable special offers just for you this August. Become an Editionista with customized jewelry from Thomas Sabo's Special Edition collection, giving you a whole lot of sparkle and individuality at a truly spectacular price. And discover what good-looking grilling really means with a Weber 57cm one-touch premium charcoal grill plus cover in a range of trendy new colors. So, what are you waiting for? Press OK or visit dstv.com for more info. DSTV, so much more exclusively for you.
The Stars in Education Awards celebrates teachers who go the extra mile in their communities. Are you or do you know a teacher that is involved in an extracurricular and community improvement project that makes an impact outside of the classroom? You do? Be a part of building excellence in education and submit your entry today. Enter online at www.ed.org.za or post your entry to the Stars in Education Awards, Free Post CB 8152, PO Box 7177, Stellenbosch 7599. Entries close on the 31st of August 2012. The Stars in Education Awards is sponsored by Transnet Foundation, Mindset Learn, Macmillan, Cell C, The Star, Metro FM and Argo.
Welcome back, Mindsetters. As you know, we are doing grade 12 data handling and manipulation. It has been such a fantastic show so far, and I know that you guys have enjoyed every single second of it because the likes on the page are also on the increase. And our Mindset crew and team and Mindsetters being you guys are getting bigger and bigger every day, and it's just so exciting to see so many new people on the page. I mean, we love new people here at Mindset, so that's why we are so welcoming, and we also urge you new people to get some more new people so that this can be the whole country and other countries. We have people from so far away, Zambia and everywhere. So I know our Mindset team is getting much bigger. Over to you, Heather.
Okay, guys, the last segment, I was ready to move on to the next question, but what we did get was an urgent plea from one of you out there, and it is to say that you don't have the Casio calculator and you're sitting with one of those old calculators which has just got the old push buttons. And the question is then, how do you do the standard deviation, all right, on one of those old calculators? Now, literally, guys, what I have done here, I could have done on any old calculator, all right? So really, let's go back to grassroots to make sure. So this is what your page would look like if they said to you, work out the standard deviation. Now, in order for the standard deviation, you need to know your mean, okay? Now, remember, that's just the sum of all your scores. So your mean is your sum of all your scores, all right, divided by the number of scores. Now remember, sigma just means sum of. So you add up all those 10 numbers and you divide by 10. And so we've got our mean as being 550. Now, if I've got a score of 440 and I want to take away 550, then clearly on any calculator, that comes to minus 110. 520 minus 550, of course, comes to minus 30. You don't need sophisticated technology to be able to do that on your calculators, okay? 480 minus 550 minus 70, etc., okay? This column is literally take your answer from that column and square it. So you're going to, on your calculator, put in, and whether you put in the minus or not makes no difference. You're going to take 110 times 110, all right? And that's going to give you 12100. You're going to take 30 times 30, and that's going to give you 900. You're going to take 70 times 70, and that's going to give you 4,900. Okay, and so we go, all right? So each of those is just a methodical, plug it into your calculator. Now, guys, once you've done that, and you've got all 10 of these scores, now what you're going to do is you're going to take, on your calculator, you're going to take 12100, all right, and you're going to add on the 900, then you're going to add on the 4,900, and you're going to keep on adding all these together, and once you've added all of them up, you're going to get 47650. Okay, now 47650 is the sum of this column. Okay, now again, what we want to do is we want to actually take that answer and we again, like we did for the mean, we are going to divide it by the number of things that we added together, and that came to 10, all right? And that you can do on your calculator, any calculator. My worry, though, is that your calculators have a square root, all right? If your calculators haven't got a square root, you're kind of a bit messed here. But But once you've got your answer to that, you hit the square root, and your answer would land up coming to be 69,03. If you don't have a square root button, I think that you would have to just guesstimate. In other words, try and work 50 squared. Does that come to the answer? 60 squared, 70 squared, and you can kind of settle at a value. But I'm almost certain that even the most basic of calculators have got a square root on it. Okay, the last question that I want to have a look at is really to do with something called bivariate data. All right, and bi meaning two, and the difference with this is normally that you get two different sets of information that are kind of related, okay? So this question says, a motor company did research on how the speed of a car affects the fuel consumption of the vehicle. And the following data was obtained. So let's just say that you're the manager of a delivery company and you are spending hundreds of rand a month on petrol for your vehicles to go and deliver stuff. Now you want to try and work out what is the best speed for your vehicles to be traveling at to stay within the law, first of all, but also so that it affects your petrol consumption, so that it actually works out that you use as little petrol as possible. Okay, so notice that obviously this particular vehicle went out, and when it did constantly 60 kilometers an hour, that's how many liters of petrol it used to do 100 kilometers. Exactly with 75 and so on. Now, the first question says represent the data as a scatter plot. Now, guys, if you get a question like this, I honestly believe that this is your kind of feel-good freebie question because it is so easy. Right, let's not mess it up. So let's have a look at what we've got. All right, normally they do indicate, all right, which is X and which is Y, all right? However, if they don't indicate, you must think to yourself, what are they trying to work with? They're trying to vary the speed to see the effect on the fuel consumption. So speed is going to be your independent variable, all right? So I'm hoping that you're along with me there. That's independent, and depending on your speed is how much fuel you're going to use. So this is going to be your y-axis or your fuel consumption, all right? And they give marks for little things like labels, all right? So this is your fuel consumption, and the other axis is going to be your speed in kilometers per hour. Okay, now setting up your scatter plot is not something that you must do in a hurry, okay? Give it a good minute or so. Notice that the lowest number is a 60. And if we scan, the highest number is 120, all right? And here your fuel consumption, your lowest number is 7.8, all right? And your highest number is 11.5. All right, now think logically. If your lowest number is 60, do not start your x-axis at 0. Okay, because you're going to have 0, 10, 20, 30, 40, 50, 60, and all your data is going to be over here. So I'm going to start at 50, and then scaling up in tens, I'm going to go 50, 60, 70, 80, 90, 100, 110, 120, 130. And when I say scaling up, mine doesn't look exact, but it must be to scale. So measure centimeters. Okay. Right, let's have a look at the Y data. Can you see that it's actually quite important for me not to go in tens because I'm needing 7.8s and 8.9s. 7.8 is the lowest, so I'm going to start at 7 and go up to 12. So here I'm going to have 7, and then I'm going to have 8, 9, 10, 11, and 12. Okay? Notice that I've got a scale of 1 centimeter equaling 10 units on the bottom, and here 1 centimeter equaling 1 unit going up the y-axis. That's absolutely fine. Okay, and you'll see that the way that I've set up my scatter plot, I'm going to get my data happening over here, and it's going to be big enough for my examiner to have a look at it and for me to actually interpret what's going on. Okay, now I'm going to literally go and plot each of these points. So 60 with 11.5. Now I'm hoping that I'm going to be able to get it as accurately as possible. 60 with 11.5, and it just moves a touch, so let's try again. 60, 11.5, hopefully looks somewhere like that. Okay, then I'm going to keep on going with my data. I've got
Heather,
yes.
we are so out of time.
Are we? Okay, well, let me just very quickly. Guys,
No, well,
when I do my data, when I
Yes,
land
there
up
you
with
go.
my data, ever so quick. Are we out of time completely?
yes, completely,
Okay.
completely.
When I look at my data, it looks something like that. Okay? And the question is, what kind of graph is that looking something like? Is it straight line, parabolic, or exponential? Well, it looks
Okay.
exponential. Okay? I mean, it
Yes.
looks parabolic. And then notice that there will be a small
Kevin,
point.
we're going to have to wrap up. I'm
Okay,
sorry
goodbye.
about that. Sorry about that, Mindsetters. Bye. Thank you to Liberty as well. You guys were absolutely awesome. Learn more and learn extra, guys. Bye.